In this lecture, we're going to talk about parametric equations. And really, today's lecture is kind of a review of probably what you learned maybe in pre-calculus. But for a lot of people, it's been a while since you've dealt with parametric equations, so this is just sort of a refresher. Now, when I think of parametric equations, I think of physics, because, and maybe I like physics, but but um, oftentimes the equations of motion are expressed parametrically, and really vector equations are parametric equations. So a classic example from physics would be projectile motion, where you've got movement in two dimensions. You've got an x dimension and a y dimension, and you can express both of those in terms of time, right? So let's take a look at this first example. A ball is launched at a 45-degree angle from the ground level, and the ball's vertical displacement, y, in meters above the ground, and its horizontal displacement, x, in meters from the launch site, at t seconds after launch are described by these equations. Okay, now we're not going to worry too much about where the physics behind them, but it'll simulate the trajectory of a ball in flight, projectile motion, essentially. All right, so let's just graph this out. What do we got here? We've got I could just put in these t values for x, right? And if I put in t for x, right, x is just 20t. So we've got this constant velocity in the x direction, right? So 0 after 1 it's seconds, yeah. So we've gone 20 meters, and then after 2 seconds we've gone 40, and then 60, and then 80. Okay, so I'm just putting these values of t into the equation for x and getting x values. Now in the y dimension, we've got gravity involved, so we've got the acceleration of gravity. Force of gravity pulling this ball down. So it's launched with an upward trajectory, but the gravity is acting on it and pulling it back down toward the Earth. So again, I'm not going to worry too much about the physics, but we'll just take this equation and plug some t values in for it. So we put in 0, we get 0. Plug in 1, right? We're gonna get essentially minus 5 plus 20, so we have 15. And plug in 2, we get 20. We plug in 3, we're back down to 15. Okay, and then plug in 4, and you're going to get 0. Okay, so just plugging in numbers. Now let's take a look at what that looks like. So here we are at t equals 0. This is the point at which the ball is launched. And then we have at t equals 20, we're at 15, so I can plot that point. At 40, we're at 20. And then at 60, the y value is 15, and then at 80, we're back down to 0. So you can see it's kind of what you would expect for the trajectory of a ball being launched, right? It's this nice parabolic curve. Let's see if I can draw it. Okay, that's not too bad. All right, and so I could draw the trajectory. So the ball is going to travel. So here it is at t equals 0, and at t equals 1, we're at this point. It's traveling in this direction. So here we're t equals 2, t equals 3, and finally at t equals 4, it hits the ground. Okay, so that's a parametric equation, right? Those are parametric equations for the vertical and horizontal motion of a ball launched from the ground. So, all right, so let's take a look at something a little bit more abstract. I'll let you go ahead and take a look at this, and just go through the same process. You've got a bunch of values for t, plug them into the equations for x and y, and then graph it and see what you got.